And hey, is this going to work? Awesome. So today we're going to look at what is computer programming. Now, in the other class, people have sort of suggested or asked, why don't we jump straight into programming? I've done that in the past, and it works well because people start programming the first week, but that doesn't actually help you learn sort of the background of programming, why it exists, why we're programming the languages we do, and also sort of start planning out things. And planning is a huge part of coding. If you open up your IDE, where you code, and start coding without planning, you're going to have a bad time. Okay, so it's not good. So planning is a big part of it. So we need to learn the background to things. So yeah, Chuck Norris, he stares at computers. So today we're going to look at the history of programming, the different generations of programming. That should say programming languages, the types of programming. Not so much on that one. But then we're going to look at the different programming languages. Okay. Programming is problem solving. It is. It's having a problem that you've got to solve, whether that be most hands-on activities are problem solving. You've got to build this thing to service a certain job. But programming is that you're given a task. You've got to have certain inputs. You've got to do something with that data, and then you've got to output it in a certain format. It's not good enough always just to output it. You have to output it in a certain format. And so that's the problem solving. You've got the data, you've got loose data, and now you've got to present it in a certain way, and that means processing it in some way. And that could be really, really complex, like writing an operating system, or it could be really simple, like adding two numbers together. Okay, but it's all problem solving. You've got to get the data, you've got to do something with it, you've got to output it to something. It's not if you just want to play around with Minecraft all day. It's not if programming is not the subject you choose, if your whole decision-making process was, well, I spend all night on the computer playing computer games, therefore I must be good with computers, therefore I must be good with programming. It's not how it works. Okay? It's not easy. Okay? It is difficult, but when you get to that moment when it actually works, to me that's the exciting part, when you've got an application or a program that actually works. That's the sort of the exciting thing. So yeah, just wanted to give you an idea of, it's very, very cut down basically what programming is and what programming isn't. Alright, I listened to the video that I did yesterday and earlier in the week, and I say alright a lot. So I'm going to try and cut that down. I do apologise for you listening to the video or watching the videos later, but if I do say alright, I apologise now for it. And I was about to say it then. So, most popular programming languages for last year, I can't remember where I got this from, or codeeval.com. I don't know how accurate this is. I'm assuming it's accurate, 100% accurate, but Python and Java are the two largest programming languages by quite a bit, actually. And so we're going to be learning both of them, Python and Java. And they do the same job, they do programming, but they do it in quite different ways. The syntax is quite different. So we're going to be looking at both of them. And C++ is still pretty popular. Does anyone know why C++, even though it's a much older language, does anyone know why it still exists and why it's still relatively popular? It's good. It's incredibly hard to program. It's not easy. The syntax is quite tricky. Yes, games would be programmed in C++. Does anyone know why?
It's more integrated to Windows, so it's faster. It's not in the virtual environment.
Not so much that it's integrated with Windows, but it's much faster. That's the key bit. It's much faster. Java, we'll talk about this a bit later, but Java was created for a particular purpose, and speed wasn't a high priority. The running of the code wasn't a high priority. Whereas C++, running code fast is a high priority. So operating systems, a lot of it would be written in C++, or maybe it's written in another language, and like Microsoft to say, okay, this is all good, but I don't know, saving to the hard disk takes too long. It's unacceptable. So we'll optimize this code by writing it in C++. Or something like that. They might even do it in an assembler language, which we'll talk about in a second. So they can optimize parts of the code in different languages. But games particularly, because it is so fast, and games you do need speed for a lot of them, unless you're playing that crappy Candy Crush, whatever it is, speed is not so much of an issue. But if you're playing a 3D world sort of Team Fortress 2 game, you do need speed. So yeah, you need it to react quickly. So anyway, I do apologise for this next screen as well. This is the best sort of graphic I could find for this, but there's no way you can read the details. I can put this picture up on Google Drive if you want. I found it. It's quite large. I had to scale it down to fit in there. But this is basically the history of programming languages and sort of how each programming language relate to each other. Now, it's not important at the moment to see exactly where each languages are, but if I can read this properly, and it's really blurry, over on the left-hand side, I think that's 1954. Let me see if I can make it a bit easier for me to see. There we go. 1954, all the way over here, up the top, the green box is Fortran. So according to this is not true, but Fortran was the first programming language. There was ones before that. But 1954 is Fortran. And Fortran existed all the way to 1983. And then it just stopped working, apparently. It's not exactly true, but it just sort of just petered out a bit. But there, see there's branches of them, so they all relate to each other some way. And there's a few other important ones in there. It only goes up to 2001. That's on this end, so there'd be new ones popping up there. And there's a lot more programming languages than this screen. So I just wanted to give you an idea of sort of how they all relate to each other. Some of them don't relate at all, like the one at the bottom, Basic, down here, sort of started by itself and just keeps going, and it's now Visual Basic, but it's all the sort of same programming language. So yeah, just wanted to give you an idea. But as I said, I'll put this up on Google Drive so you can actually look at it if you're interested. The ones we're interested in, let me go back here. Ooh, animation. Java and Python. They're the ones we're looking at, and they were apparently created in 1991, so they are older than you. Hooray! Now, you can see Java had some inputs. One of them was Scheme 84. I've got no idea what that is. It's a programming language, I'm guessing, but I don't know that one. But it's also got whatever K80, the red box on the left, and whatever comes down here. It's got a few sort of inputs that's related to those ones. Python started from ABC and a couple of ones down here. Python, by the way, was named after Monty Python, because the guy that created it said, I like Monty Python, so I just call him my programming language Python. So, who knows? Monty Python might appear in any assignment. I'm also a fan because I'm Mac oriented. I'm also a fan of Objective-C because not all the code, but most code you write for the Mac and for the iPhone or iPad, they're all written in Objective-C over here. So that was actually created before Java and Python. What was that, 1983? So yeah, and it just sort of keeps going by itself. Nothing much has happened with that one. But anyway, Java and Objective-C are C-based languages. They've all got a root in C. Anyway, so that's what we're working with. I just wanted to give you an idea of the world of programming languages. Okay, the generations of programming. When they first invented computers, it was great to have a computer, but unless you had a programming language to program it in, it wouldn't do anything. It just sat there and it was just equipment. It's like having this computer off. It just doesn't do anything. So they had to invent a programming language. The first one, or the first generation of languages, were computer-specific, like absolute computer-specific, not the type of computer. There were no Macs, there were no Windows machines. It was computer number one, computer number two, and you had to write your language for that computer. So this is why it's called a generation. First generation of programming languages, they're all zeros and ones, and you had to program it by punching holes in this card, which is why they're called punch cards. And there were boxes and boxes to write simple code. Boxes of simple code. And if there was a problem with the code, like there was a bug in the code, you had to reload the entire box. You had to first of all find out where the problem is, fix it, and then repunch all the cards, and then reload the entire code. And then it would have happened a lot, because also these computers might have had to take all night to process a simple program. Sorry, and so you would have come in the morning, find out the computer had crashed, and then sort of had to do it all over again. So it wasn't easy. So yeah, it was. Just speak while we're on this. Does anyone know where the term computer bug came from? Like, what's the origin of the computer bug?
No.
Anyone?
Virus?
No. No, this was before viruses.
Ate the cards.
Sorry?
The bugs ate the cards.
You're kind of right. You're on the right track. Basically, it does come down to moths, cockroaches, bugs, like animals. Because what happened was these computers in this first generation, sort of the 1950s roundabout, these computers took up like the size of this building. They were massive, and they had the processing power of, nothing. But at the time, they were really impressive. But they took up the entire room. And now a building of this size, you cannot protect completely from bugs. It's virtually impossible. So when the computers crashed, it could have been because, the story is that the computer crashed because a moth had got fried on one of the components and it crashed the computer. So it was actually a bug in the computer that caused the crash. So that's where, and now it's bugging, you use the term, you got a computer bug in the code rather than the computer itself. But that's where it came from, these massive computers that cockroaches got fried in because it's just exposed electricity. So anyway, so that's it. So that's what you had to program on in the 1950s. Very hard to read.
Yeah, binary.
Binary, that's what you had to do. That was punch cards, basically. It was all binary. I don't know. I don't think that code does anything. I think when I wrote it, I just typed in zeros and ones a lot. But, you see what happens. The next generation of code was called the second generation. Imagine that. And this is sort of closer to English. It's called assembler. And the code on the right, this is assembler code. I can't remember exactly what this code does. I think all it does is multiply a number by 8. I think. I can't remember. I'll have to dig that up. I'll find it somewhere. But actually, I might have let me have a look. Oh, no, sorry. This code snippet divides the number by 61. And that's what that does. I don't know how. I don't know assembler code. I did know at one point. But again, it depends on the particular processor type you're looking at. But this divides number by 61, according to the website I got it from. So yeah, not easy. Especially when in Java you can write one line of code, which is number divided by 61, and that's it. But assembler code is really, really fast. Like I said, some operating systems, some games will be optimized in assembler, so it makes it even faster because it is super, super fast. It doesn't worry about all the stuff going on in the computer, it just worries about what's happening in the CPU. So it's really quick. Anyway, so that's it. The third generation, which is what we're sort of currently working in at the moment, they're called high-level languages, and they're even closer to English, or a spoken language. And most of them are English languages because the programming languages were invented sort of in English countries. So they start introducing some structures into codes. Assembler codes, you just write a whole bunch and have a lot of go-tos. Go-tos in programming are bad, but you sort of were forced to in assembler code. These now introduce loops, decision-making, things like that, and they're a lot easier to read and write. So that's where we're working at the moment. The fourth generation is what's termed high-level abstraction. It doesn't actually worry about what computer it's running on anymore. SQL, for those people who've done any database work, that's an example of, sort of the main example of a fourth-generation language because it doesn't worry about the computer, it doesn't worry about the database. It just says, I'm going to send you a command and you work it out and give me some data back. And the database has to handle it. So it's an example of a fourth generation language. And the fifth generation, which doesn't really exist yet, that's artificial intelligence. So the idea behind that is you can give this computer a command and the computer has to work out how to do it. So you might have this robot and you just issue a command, whether it be voice or whatever, and you say, I want you to get over there and kill that person, they're really annoying me. I'm not actually using you as an example, I'm just over there.
What about that robot by one that like brings people drinks and all that now?
I don't know that one actually off the top of my head. I mean, we're getting there. They're still not. I mean, that might be an example of a fifth generation or artificial intelligence, but it's still not mature. They're still very, very basic. And yeah, so, and of course, I had to put Star Wars in there. But there's still sort of, it's based on the actual computer itself. They have to configure it for that computer because of the components and all this sort of stuff, but we'll get there eventually. All right, so as I think I've said, I just put silly pictures in when I'm doing presentations because I get bored when I'm running them, and I sort of switch between doing my work and Reddit, and I sort of they bleed into each other. So that is there just to piss people off. Is anyone annoyed by that picture?
Yes. The fact that it's on Han Solo, yeah.
Excellent, not Han Solo. Yeah, that's a start. Yes.
Yeah, it was by
It's very
Spock,
much so.
and
That's
that
Spock.
guy's not even from. He didn't even say that. And his name's not Han Solo.
That's right. Yes.
It's Castle.
Yeah.
In that photo,
No!
the main guy. Firefly.
Yeah, that too. Don't watch Firefly, no Charlotte
S is on the list.
You'll never watch Firefly. I'm going to make an assignment that you'll be forced to watch Firefly. There's like 12 hours of footage. That's it. You could do it in a day. You can do it in a day, and then your parents can say, no, Ryan said I have to watch Firefly. So the assignment could be something like, step 1, watch Firefly. Step 2, write a program that adds two numbers together. So they don't have to relate to each other, but if the assignment says watch Firefly, then you can tell your parents. And Live Long and Prosper was said by Spock, which is in Star Trek. Han Solo, Star Wars. That guy is from Firefly. What's his name in Firefly? This Firefly was made in like 2002. Castle was started in 2008. Let's say.
He's still Castle.
Anyone know the character name? Malcolm Reynolds. He's a captain of Serenity. Oh man. I don't know if I'm getting old or you guys are just uncultured in geeky stuff, but you know, probably.
I'm sorry, this is trying to work on Stargate.
Well, you know. All right. Anyway, it's an issue for me to get over the fact that you guys, you know, are shocking and don't know Firefly. Seriously, it's science fiction. It's dramatic and it's funny as well. And it's got cows. It's got cows in space.
Does anybody get reminded by Sheldon Cooper from this? He's just like, the worst part of my life was when they cancelled Firefly. Just like, that is...
And how, if you watch that show, that's cool, that's up to you. I don't make judges on your life decisions. But if you watch Big Bang Theory and they mention Firefly and you don't watch Firefly, what are you doing with your life?
Don't watch Big Bang Theory.
Exactly, don't watch it. Again, I don't make life decisions.
I watch it when it's like, there's a bit on YouTube where it just pops up saying, oh yeah, Sheldon mode. Okay. So...
Okay. I have not had enough coffee for this. All right. Anyway, I'm gonna have to cut this bit out of the video before I publish it because. Yeah. Seriously, it's in space. There's cows, you know, and there's a guy in a Hawaiian shirt. All he does is wear Hawaiian shirts.
Give us sales pitch. Sell it to us.
It's written by Joss Whedon.
Star Wars, Lord of the Rings. Does that help?
Yes, it helps slightly. Joss Whedon. Does anyone know Joss Whedon? Okay, what do you know Joss Whedon from? Buffy. Okay, cool. You're all right. Buffy's all right. You're good.
That's fine.
What? Buffy, excellent.
Dollhouse.
Dollhouse, awesome. Anyone else? One of the biggest movies in the last 2 years. The biggest movie in the last couple of years. He wrote, directed it, and possibly produced it. I'm not sure. The Avengers. Did anyone see the? Did anyone see the Avengers movie? Yes. Joss Whedon created that. He didn't create the Avengers. He wrote it, and he directed it. He also did Firefly.
Okay.
The way I think about it, he created Buffy. He also created Firefly. He also did this thing called the Avengers.
So that's why there's some issues in Avengers. We're still getting over that Firefly.
There's not. Joss Whedon doesn't do anything wrong. He's perfect in every single way.
I think we have some like kind of gay love going on more since you
Not some kind of. There's few people I would turn gay for. Nathan Fillion is one. This bit I'm definitely cutting out. Joss Whedon is another. No. It's they are brilliant men. Anyway, there's nothing wrong with having man crushes. That's okay. You know, Hugh Jackman is another one of mine. It's okay.
Johnny Depp, my personal favourite.
When Hugh Jackman's on screen. Seriously, when Hugh Jackman's on screen, I tell my wife to leave the room. I'm definitely cutting this out. I cannot have this online. It's not cool. All right, let's get back to programming. All right, software development. I'm getting quite embarrassed now. All right, software development. Some skills you have to be a software developer, to be a programmer. You need to be able to problem solve, like I already talked about. You need to look at a problem and pick it apart to be able to find key things that you need to address later. You might be able to need to be able to pick out sort of minor sort of sections that you can solve in different sort of segments. I didn't say that right at all. You need to be able to pick apart a problem into sub-problems. Okay, so a problem like an operating system, it's not just I need a computer that can, I need a program that can run other programs. It's not that easy. Creepy eyes.
Sorry.
Focus.
I was,
That's
looking
okay.
at the mirror and then I was like trying to get my contacts to get back in place.
Okay, contacts. Okay, that's okay. I've worn them before. I know what it's like. Because sometimes they just move.
Yeah.
It's really weird.
Sorry.
No, it's okay. It just freaked me out for a second. I thought you were possessed.
He was in like fourth
Yeah,
grade.
part of also software development is research. If you face a problem that you don't know the solution, you need to be able to Google it. You need to be able to Google it and pick out relevant parts of different websites to be able to apply it to your situation. And I will warn you now. I do apologise. Actually, no, I don't apologise. Bugger it. There will be times when you ask me how to do something, and I'll say I don't know, but I will be lying. Okay, I will lie to you. I will say I don't know how to fix it.
But lying is bad.
No, lying is okay. But
I'm telling that to my parents and they're just going to be like,
No.
no, a teacher told me so.
no, I will be lying to you because me lying to you is a way for you to force, for me to force you to research. You need to be able to Google it. Okay, I might point you in the right direction.
You just say
I-
How
Google
many
it first.
teenagers can't Google?
Sorry?
How many teenagers can't Google things?
People can Google. People can't Google well. There's a big difference between Googling and Googling well. And not only that, but once you Google it, I'll get you in a second once I finish my thought. Once you Google it, the next step is to pick out the bits that are relevant because there's going to be sites you find that huge amounts of technical detail, and you need to read the one line or the two lines that relate to you. Okay, and sometimes that might mean also finding the two lines and then reading the backstory to get to that point. So research is a huge part of it. Yes.
Today the last day you can change subjects.
I don't know. You have to talk to Helen. I'd suggest if you're not interested, if you need to talk to Helen
No,
today.
it's not that I'm not interested. Just it's okay.
Yeah,
He just really doesn't want to watch Firefly.
then I'm going to kick you out anyway. And you need to, and part of that research is you also need to read other people's code to be able to pick out the bits that you need, particularly my code because you're going to need to read my code. All right, very, very on a basic level, computers are made up of hardware and software. Sounds really stupid and really basic, but it is. We're not worried so much about the hardware. When you get to next semester and we do the Lego robots, then yes, hardware is going to become an issue. When we do microcontrollers, the little Arduino boards, definitely hardware is going to become an issue then. But this semester, we're worrying about software. Okay? And because these days, particularly, like even 5 years ago, most of the programming would have been done on a computer, and that's it. You would have published your program for a Windows or a Mac, and it would have been run on a computer. But these days, the computers, there's mobile phones, there's Arduinos, there's Raspberry Pis, there's all these sort of embedded devices that you have to program for. So it's really changed in the last 5 years. It's very exciting. All right, I said it again. Damn it. Software is made up of the 3 stages, and all software is made up of these 3 stages. Really, really cut down, basic version. There's input. You need to get some input from either the user or another part of the program or another part of the system. You need some input. You need to process that data, whatever the program needs to do, and then you need to output it in a certain format. So it could be something like reading a file from a hard disk. You need to load it into memory, and then you need to print. That's the 3 stages of input, processing, output. All software does it. And then within that, like Microsoft Word, for instance, you've got to open up the file. You might need to type some characters, and then you need to save it or print it. Now, even in that, the typing the characters, even that requires extra input, processing, output, because it's not as simple as pressing a key on a keyboard and suddenly Word displays the character. There's actually processing involved. First of all, it's got to determine which character you pressed. It's got to load that character, that ID number, up from some sort of bank of memory, and it's got to somehow display it on screen. It's not as simple as you would expect. To do it on a basic level, you've got to. There's quite a lot of processing involved. But anyway, so that's the sort of 3 main phases. Now, programming languages. We're getting into programming languages now. Back to that. Each language has a purpose and a syntax. Okay, syntax is going to be the main thing that you notice when you're programming, because every programming language is different. They might be similar, but they're going to be different. The purpose is more hidden and may determine which programming language you choose for a particular task. So, for instance, this semester it doesn't really matter what language we choose. That's okay. I've chosen Python and Java for you. Next semester we've got the NXT robots. You're sort of forced to use a C-based language because it has a purpose. It needs to run code on this device. So you're forced to do that. When we do Arduino, you have to write a C language as well. But it's a different C language than Robot C. But they've all got a purpose. All right. I've said it again. I apologize. This table, you don't need to memorize it. Don't worry about this. This is just an example of some languages and the sort of difference between them. So this is more of a sort of, not so much the purpose, but the decision about why languages exist or why they were created will determine some of these sort of choices. So Java, for instance, looking at the first line, object orientation, Eiffel is a pure object orientation language, or that has that characteristic. The reason for that is Eiffel, I believe, was a language created to teach programming and to teach object orientation. So they had to make it proper. Now Eiffel, as far as I'm aware, because I learned it at uni sort of over 10 years ago, it's an awful language, but and it's really, really slow because it converts Eiffel into C++ first and then into assembler and then runs it. So it's really slow, or at least the system I use. It might be better now, but I think it's died off. Yes.
What's that Capers Jones language though?
Sorry?
The bottom one, the blue one.
I have no idea.
Okay.
No idea. Yeah. I'd have to go to the website because I've got the URL here. I'd have to go to the website to find out and do some research. As I said, the details on this don't matter. I just wanted to give you an idea that not all languages are the same. Okay, they do different things and they do it in different ways. So Java we're doing is a hybrid in terms of object orientation. I don't know how they determine what hybrid is, and Python is hybrid as well. What's another example there? Something that's going to affect this semester. No, these are all sort of more object-oriented stuff. But anyway, I just wanted to give you an idea of why there are different languages. They're not every piece of code is run in Java, for instance, because it's an easy language to read. There are reasons for it. So if you need a pure object-oriented language, you don't choose Java. Okay. Sometimes you don't have a choice. If you get a job, you get told what language to run. Or, like when we do NXTs, you're forced to use Robot C.
Like the example of your friend, how you had to change to languages.
Yeah, over the weekend he had to learn Java because he knew I can't remember the exact languages, but he learned a programming language over the weekend because he had to. Anyway, syntax. Syntax is really important for programming language. Not so much for language, like spoken language, because humans are intelligent creatures generally, and we can fill in the gaps and make assumptions about what people are talking about. Especially when I talk, there are gaps in what I say, and I forget words, and I use words that may not work properly or work good. So, but you can work it out because you are intelligent, sort of conscious beings. You can work it out. Computers are stupid. Okay, they're basically stupid. You need to tell them exactly what you want. Exactly, precisely, no confusion whatsoever. Now, I'll put that quote up there, A, because it's Star Wars, and so, if you don't like it, suck it. But I'll put that up there because Yoda speaks English, or in Star Wars universe, it's called Basic.
Yes, he does.
Yeah, but he speaks Basic, just to put that out there. He doesn't speak English, they speak Basic. But he speaks English in a weird syntax. But we can still understand what he's talking about because we can fill in the gaps, and we can, our brains can rearrange the syntax to work out what he's talking about, or hopefully we can. Maybe it's because I've watched Star Wars like 300 times each movie, and I can work out exactly what he's talking about. But it's not proper English what he's saying. The syntax is incorrect, but we can work it out. Computers, we don't have that option. We have to be exact. This is an example of Java code that I wrote that does something very, very, very critical to the life, the universe, and everything. But the syntax is specific to each language. Python code to do exactly the same does not look like this. For instance, Python doesn't have these curly brackets, for one thing, and curly brackets takes up probably 20% of that code. There's a lot of brackets in there.
Everything and closes it.
Yeah, Java, for every open bracket, you have to have a closed bracket. You don't have a choice. You can't say, the Java will work it out. You don't have a choice. Every open bracket has to have a closed bracket. So this open bracket here, and I know this, and we'll learn this as we go through. This open bracket here relates to this closed bracket, and that one has to be there. Or it can be anywhere on that line, or like around, but it has to be there. It has to match this one. These two open closed brackets here, they have to match, and they have to be there. They can't be on this side of that bracket. They have to be there. Syntax is really, really important. Okay, you don't have a choice. This code, I don't know where I got this code. I've written this code and it doesn't really do anything, but it's just an example. It has an array. We'll talk about arrays later. Has an array. It adds my name to the array, and then searches another array. Oh no, sorry. Yeah, it uses another array and then adds two numbers together and then outputs it. I don't know. I think I got this code just more of an example of how to do functions or methods.
I did about 4 or 5 lines of that whole thing.
Sorry?
I only understand about 4 or 5.
That's fine. That doesn't matter if you don't understand any of it. That's okay. We're gonna by the end of this semester you will understand that. And you'll also understand how useless this code is. But it's just an example of syntax. The other thing that's important, not so much for Java, but for Python definitely. Like Java is really picky about these brackets. Python is really picky about indentation. Okay, so I've indented this code. So this line starts there, that one lines up with that one lines up there, and then it goes in there. And there's a particular reason for doing that, and I'll talk about that later. That's not so much important in Java. In Java, all the code could be completely lined up against the side of the window, or I could actually write it on one line and just write it all with no return characters whatsoever, and it would still compile and it would still run. So it's not fussed about that. Python, you have to have the indentations. It doesn't, or the indent. It doesn't work without indentation. Okay, so it's just different sort of reasons for it. But yeah, some programming languages care about white space, indents or return characters. Some languages don't. So it's just there. I've got no argument for this one. I just found it funny when I was on Reddit. So yeah. All right. All languages, all high-level language, all third-generation languages, they have these common attributes, 5 common attributes. Arithmetic, maths, they can all do maths. A programming language without maths is pretty useless. Okay? They all loops, which is a repeating code until a certain condition is met. Hopefully not infinite loops. They can make decisions, if this number is bigger than this one, or this one's less than this one, or is this in the range of this number, that sort of thing. They can all do that. They can all store data, and that could be either on a hard disk, like physical media, or it could be into memory, or all those other things. And they can do what's called internal documentation, which is code. Now, in my example back here, this one, I don't have any code to show you, so that's kind of useless. They can all do comments in the code. Okay, I've said it again. I'm really going to try to cut down on that. There are two types of ways of running code in any language. So in programming languages in general. Interpreted and compiled. What interpreted does is when you write your block of code, it will run the first line of code, and then run the second one, and then run the third one, and run the fourth one. If you've got a syntax error or a problem in your code later on, it won't detect it until it gets to that line. Compiled, what that does is look at the entire block of code first, compile it into one executable, and then run it then. So you'll find out if there's any errors or syntax errors before you run it. Java is compiled. You have to compile Java code. Python, I thought it was, depending on which one you use, which system you use, could be interpreted or compiled, but one of the guys in the other class was saying it's interpreted only, but I have to check that out. But yeah, Python I think is interpreted as well. The programming lifecycle. This is the cycle that I want you to get in the habit of when you write code. Okay, there's five main steps. First of all, you have to work out what the problem is. You can't solve a problem without working out what they're actually asking. Then you need to plan it. Planning is a huge part of programming. Okay, it's something I don't do enough in class, and I'm going to enforce that upon you. Unfortunately, I'm going to force you to plan. Luckily, we've got some tools that help you plan and make it to save time later. Then you actually code it. You code it Java or Python or whatever. Then you test it. Testing, again, is a big part of it. And then you lather, rinse, repeat. Okay, because you'll get to testing, and I guarantee, except maybe in the first couple of weeks, but once we get into more complex code, you will always find problems with your code. Always. There will be times when you can't work out why your code doesn't compile. Or there will be times where you get the incorrect answer, and you have to go back and fix it. So you'll always be in this cycle, working out the problem is, planning the solution, coding the problem, testing. You might only go back to coding, or you might have to go and plan the entire software again. So yeah.
Java could be a capital letter.
Could be a capital letter, it could be a lowercase letter, it could be a semicolon, it could be anything. It's all these different things. As I said, testing is really, really important. It's working, but I have no idea why. This actually happened to me. I wrote some code and I thought it would fail, and it actually worked. And I couldn't work out why it was working, which really scared me. So yeah, it might be funny, but it does actually happen where you go, holy crap, it worked, and I can't work out, it shouldn't have worked. Yeah, anyway.
Before, and then you take it apart to try and figure out how to put it back together.
And it breaks, yeah, exactly. There's two types of errors, syntax and logic. Syntax is easy to fix because, particularly in Java, because it has to compile the whole thing, it'll tell you if there's a syntax error. That means there's a bracket in the wrong spot, there's a typo, semicolon, a capital letter. It's just typo stuff. Logic errors are much harder to detect. Now, logic error is when the program doesn't do what you expect, doesn't give you the answer that you expect. So, for instance, if you wrote some code that added two numbers together, and I entered 3 and 5, you would expect the answer to be 10. Yes. Wow. Okay, cool. You would expect the answer to be 8. Yes. 3 and 5. 3 plus 5 is 8. But if I write my code and somehow it outputs 10, then you say, okay, well the program's working. There's no syntax errors, but the logic is wrong because I've got the wrong answer. So just because the program compiles, it doesn't mean it works. Futurearmify, that sort of thing. Okay, sorry. As I said, silly pictures. I get bored. Oh, way too much. But but my excuse is, I've got nothing. This is an example of a program which I might get you to program next week. Maybe. Yes, I know there's a slide typo in there which I forgot to fix up. You know, move on with your life. Shut up, leave me alone. Go watch Firefly. So this problem is writing a program which asks the user for a name. I think I was supposed to put username in there, but anyway. They're asking for a name, mark, and prac result. To pass, the person needs a mark greater than or equal to 60 and a satisfactory prac result. Print to screen their name and a pass-fail message with reasons. That would be an example of an exercise that we're going to do in the next couple of weeks. Okay? That's the sort of problem you're going to do, and you're going to have to test this. Now, we're not going to write in the code now, but we'll look at some sort of bit in a second. But first of all, if you've got a syntax error or a logic error, what you've got to do is do this thing called debugging, which is getting rid of the bugs out of your code. So debugging, you've got to find the problem and fix it, and sometimes you have to do this multiple times. There could be simple problems like you've got greater than or less than, instead of greater than or equal to, or less than or equal to. Or you've got more complex logic, and as we learn more and more programming, you will learn more and more. You'll find more and more greater logic problems as we go through. That's okay. Some IDEs, integrated development environments, Eclipse, which we're going to be using this semester. It's got some good debugging tools in there, and you can sort of see the values stored in your program as you're running it, which is really good. But the big one I do, and I'll be telling you to do this as you run your code, is to output the values to screen so you can see what happens as the program's running. And for me, that's a really good way of testing, just so you can see what's happening. Anyway, so let's look at this testing example. This is exactly the same question as before. It's even got the same... Oh no, this one's actually fixed. I don't have the typo in there. I've got only one user in there. Okay, but it's the same problem. They need 60 or greater to pass, and they need a satisfactory prac result as passable. You need both of those. So, we've got this sort of testing stages. Now, this is something you're going to get hopefully in the habit of doing when you're testing, is looking at the problem and working out where the important values are. Okay, and this is part of the processing. Some of them are going to be really easy, some of them are going to be more difficult. So you're going to look at what the result you want is, and okay, for this it's going to be a pass or fail result, and you've got to work out what determines that. So what, in this program, what are some key values that you need to pass? The mark. Okay, what's the mark going to relate to? So yeah, but in the other direction. Sorry? Percentage? No, there's nothing about percentage up there. No, the person's name makes no difference whether they pass or fail.
Wait, what was the question?
Question is, okay, the mark is important, but what's the value we need to test against? 60. Okay, 60 is the important number in this case. Okay, I think a couple of other people mentioned it a moment as well, but 60 is the important number. What's another important thing that would determine if they pass or fail?
Satisfactory practical result.
Satisfactory prac result. Okay, 60 and satisfactory, that's the thing and what you need to pass. So to test it properly, you're not just going to test, okay, I'm going to type in the number 60 and satisfactory and I'm expecting it to pass. You've got to test when it's going to fail as well, when the person's going to fail. So you've got to test all these values, all these combination of values. The formatting stuffed up, I apologise for the unsatisfactory. But you've got to test a value below 60 because you've got to test that condition. So that's why I've got the score equals 59 and it's a satisfactory prac result. You've also got to test if it's 59 and unsatisfactory. So they're two conditions you've got to test. It's below 60 and satisfactory, unsatisfactory. You've got to do the same for 60 itself, because this is the sort of the watershed, top of the roof kind of value, and you fail on this side, pass on this side kind of thing. 60 is the number you have to test against. You've got to test whether the prac result's satisfactory and unsatisfactory as well. And then you've got to test the value greater than 60. So I've got 61 there. It doesn't make any difference if you choose 50 or 59 or 700 or 61. It's just you've got to test the number below the number itself and above. So let's say I write my code, and when I test it, I get these results. Okay? 59 is satisfactory, I failed. 59 is satisfactory, I passed. 60 pass, 60 pass, fail. Okay, did that successfully answer the problem?
No,
No, why not?
there's a fact this 59 unsatisfactory pass.
Yep, the second one, 59 and unsatisfactory. The program reported a pass, but that should have been a fail because you need to get 60 or above to pass.
And it's satisfactory.
And satisfactory, sorry, yep. So that failed on both sides of thing. Any other problems there?
60 unsat.
This one?
Yeah.
Yeah, 60 and unsatisfactory. They got the required mark to pass, but they didn't get the satisfactory result. So those two are a fail. The second time I tested, recoded it and tested it again, came up with these results. Are these right?
No.
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 You know,
I missed the other one.
Yeah, no, 59 satisfactory is passed, it said now.
Yeah, the first one failed. Well, failed is the wrong word. It didn't give the result we wanted. So just because the point of this is not just to say, hey, you've got to test all the answers, but also just because you fix all the errors doesn't mean that you don't introduce new errors. That will always happen. You're going to introduce new errors. So just because you fix something doesn't mean you don't break something else. So keep testing. You've got to have the test plan in place and just keep applying these test plans. There are people who are employed that just do testing, and they organise all the testing banks of questions or settings, values, and they test it. Every single version they have to test. That's what their entire job is. Scumbag Steve. Don't be that guy. Don't be a Scumbag Steve or a Scumbag Stacy. Not good. All right. Planning ahead. This is where you plan the solution. So what we're going to be doing is using flowcharts. There's a software for Windows called Raptor. I talked about briefly on Tuesday, Wednesday, whenever. And that's actually good. You can not only plan your solution, but you can actually run the code or run your flowchart and test the values.
I downloaded it. It seriously looks like a 2-year-old's version of art. Like the art thing where you grab like a pen and just
Yep.
a line.
That means you're not using it properly.
No. I wasn't planning on using it. I was just looking at it.
You weren't planning on using it?
I wasn't planning on using it. I was just looking. I downloaded it for now, and then when we get to the point where we get that to use it. But then I grabbed it and I basically just put it on the screen. I was like, I have to mark. So,
Yeah, for that you're writing comments. You were just writing comments. Yeah, internal documentation. Anyway, we'll get to it. We'll learn how to use Raptor properly. It's all good. Pseudocode's another one. There's also Nashi-Schneiderman diagrams or NS diagrams. But we'll just stick with flowcharts. And as I've said before, you're going to have to repeat many steps. You might have to completely delete your code and start from scratch. That happens sometimes. That's pretty much it. So we've got about 15 minutes left, so that's good. Just a couple of key terms at the end, just to refresh your memory. First of all, input is anything to the program itself or the problem itself, your solution. Not necessarily input from the user. It could be from the hard disk. It could be from another computer. It could be for another part of your main program. It needs input into that. Programming languages. That's the other thing we didn't really cover. When you run your code, it actually converts it into assembler code, and then machine code for your computer, your type of computer. Machine code. What's machine code? I didn't put this definition because I want you to remind me. Yes, excellent. Anyone? That's how. Well, yeah, machine code is the binary. How does binary work inside of a computer? It doesn't actually send a 0 down the cable or a 1. How does it work? It's on or off. What's on or off?
Switches.
What switches?
Little switches.
There's little switches. There's a little man in there that goes, no, you go that way, you go that way, you go that way. It does it really fast.
I'm pretty sure it's an electrical current. It
Yeah.
presses it, like gives it a certain amount, and then less, and then more. And then
Yeah, basically, yeah. It's we represent it by zeros and ones, but it's electricity, and a 1 is like basically a burst of electricity, and a 0 is not. And because it's all based on timing, and this is why CPUs have megahertz values or gigahertz values, and bus speeds have these megahertz or all based in hertz. That's the time frame that it's expecting these pulses or not. So it has to work at a certain speed for it to determine whether it's a 0 or 1 because it comes through down the line at that rate. So that's how logic error. What's a logic error?
An error that comes out even though the code's working, but it comes out wrong.
Yes.
Like the 5 plus 3 is 10.
Yes. Yep, absolutely right. It's basically you're getting a result that you're not expecting. Okay, that's the sort of the English general version of it, but you're absolutely right. You're getting a result you're not expecting. Syntax error.
Error
Code doesn't work.
Error in the code. A logic error is an error in the code.
You just haven't written it right.
You haven't written it right. A logic error is the same
Code
thing.
doesn't compile.
Where it doesn't compile, what happens if it's an interpreted language?
Then it doesn't find out the error until it gets down to the line.
Yeah, that's correct. Absolutely. What's a syntax error? We still haven't defined what a syntax error is.
You haven't put part of the syntax in the right place. Like brackets.
Oh,
and
isn't
stuff.
it like
Yes.
something that we
Yeah.
can understand, but it's not entirely there? Like, does it make sense?
I know what you're trying to say, but a syntax error is you're not right. You haven't written something that matches what the programming language expects the format in. So, so like the bracket's not in the right spot, or you put a semicolon in the wrong spot, or you've made a typo or something. It's expecting a certain thing, and you haven't put it in the right spot, basically. So it's you're not conforming to the language. That's it. Any questions? Should I stop the recording first?
Yes. No. Definitely.